a CHES or CHES, of course, at that time, there was no CHES, of the year X-21 to X-19, means that for this year, CHES 2023, we give an award to a paper which is published as CHES 2022, 2023, or 2024. Sorry, 2002, 2003, and 2004. Sorry. Of course, those papers could not have an opinion. Yeah, good. And then, of course, anyone is able to nominate, and there is an open call. The nomination, the announcement of call for nomination is usually published at the website of CHES, if you pay attention to that. And usually the deadline for that is in May, June every year. And we select the awardee based on yearly rotating committee. Means that 2 members of the committee appointed by the CHES steering committee, and 3 others are invited members that they only serve 1 year. Yeah? And then they are usually, we try to get people who have been the program members of the committee, committee program members at that time, CHES 2002, CHES 2003, and CHES 2004. Yeah? From those program committee members. And if you want to get more information, you can look at chess.org/test of time. Then I can tell you about this year. Svetla, who is here. Where's Svetla? Yeah, very good. Svetla is here. And myself were appointed by the steering committee, and I played the role of the chair, but it doesn't mean that I have any particular vote. Yeah, this doesn't mean like that. It means that actually I'm giving this ceremony and organizing the things and writing the emails and meeting and so on. Yeah. And then we had 3, as I said, members who are invited. One of them, JR, who was one of the awardees of the last year. And Chris Scott, who is not unfortunately here. And also Christoph Girard, who is also not here, if I'm not mistaken. Is he here? Yeah, and then Chris Scott was also PC member of 2002. We had actually 1 person who have seen or reviewed those papers, yeah, nominated papers. And the deadline was 1st of June this year, and we received 5 nominations from, as I said, CHES 2002 till CHES 2004. And then, of course, we had a long discussion and a lot of inputs from industry, from the academia, and so on. And actually, the award goes to a paper published at CHES 2003, I can say. And you can see that the paper, the proceeding was by Colin de Walter Chetin, who is sitting here, and Christoph, who was here and probably is somewhere else at the moment. And then I can leak some information. What we got from the committee and the discussion was actually that long text, that the paper had a huge influence on both academia and the industrial world over the last 20 years. Indeed, it's difficult to count the number of publications claiming to improve the fault attack described in this paper, more than 20. Moreover, it has been used since 2003 by the industry to validate the resistance of AES implementations against fault injection. It's still the #1 fault injection test which is performed today under AES implementations by the certification labs. Can you imagine what the paper is? Huh? Any suggestion? Can you predict? This is the abstract. No, wait a second. Wait a second. This is the abstract. Yeah? Can anybody predict? No? It's hard to read, but it's interesting thing. The authors actually put some references in the abstract, which is unusual, right? But still, we completely ignore this because, okay, the paper, the award goes to this paper. Yeah. And one more thing, the paper was from UCL Crypto Group. Huh? Good. And the award goes to this paper. Wait a second. Yeah, a differential fault attack technique against SPN structures with application to the AES and Hazard. Very good. And the authors are? Very good. Gilles Piret and Jean-Jacques Quiscateur.
We have some more gifts from the organizers. So we have some more gifts from the organizers.
You see my role, yeah, as a chair.
Yeah, the microphone holder. Yeah, it is the best. So there is some picture of Prague to have good memory of Prague. So one for you and one for you, and the pictures are the same essentially. So one is for you. Thank you. And one is for you. And these pictures you can use for envelopes, for example. Okay.
Thank you. That's it. I actually have not given Gilles the certificate. Okay, congratulations to you. Thank you so much. Thank you so much for the great paper that you have written 20 years ago. And now you will have the stage to present something about the paper.
I have to say something before. But the talk will be given by Gilles. This paper obtains about 800 citations on Google Scholar. So I think that is really thanks to you that this paper is here. How many people did a citation to this paper? Whoa, thank you. I have also a short story about the paper. Okay, and it is related to sitting Koch here, because in fact, when we sent the paper, it was the editor in charge of the paper, and there was a problem because it was impossible to decompress the zip file we sent. So we spent together a day to obtain the right file. And finally, I think we use FTP for you, and it was done. But what you wrote at that time, if I don't have the paper in my box in the evening, I will refuse the paper. Oh, her. Thank you very much. Thank you.
So first, thank you very much. It's a great honor for me to receive this award because there are many excellent papers each year at CHES, so it matters to me. Now, where are my slides? What I will do is first speaking about the context of the paper and some backstory. Then basically I will redo the talk of 20 years ago, but with some shortcuts. And finally, as a conclusion, I will talk about more recent works, papers that cited the CHES 2003 paper. Yes. So, the beginning of fault attacks is folklore. Almost everyone know about the nice attack on RSA CRT. The first application of fault attacks to block cipher came almost at the same time. The AES was selected on October 2000, and at the same period, another standardization effort began. It's the NESI project. You will understand soon why it is important. So NESI project was not only about block cipher, but also about standardizing several other primitives. If you want to know more about the backstory of NESI projects, you can ask Jean-Jacques, who has many stories to tell. So at the time, I was a PhD student under supervision of Jean-Jacques, and I was funded by European projects, among which NESI. NESI organized 4 peer-reviewed workshops, and it's why I decided to look at fault attacks on some NESI candidates, block ciphers, and I submit a paper was like the ancestor of the CHES 2003 paper. The paper was pretty different from the actual CHES 2003 paper because regarding the AES, there was only the basic attack, because I also dealt with like 4 or 5 other candidates, and the paper got rejected. I remember well of one of the reviews, at least from the end of the message. So it says, "This work does not help NESI to come to a decision," which makes sense because anyway you can apply fault attack against any block cipher. Okay. And it continues, "You should rather submit your work to CHES," which was actually a pretty good advice. So to the anonymous reviewer, I have to say, thank you. So this is the paper. You might wonder, but in the title, why is Khazat? Because Khazat is not a well-known cipher. The answer is, by the way, because it was one on the NESI candidates, so it's kind of leftover of the preliminary version of the paper, of NESI version of the paper. Also, it's a nice example of a very textbook SPN structure with optimal diffusion layer. I was happy enough to be able to find the old slides from that time. The talk was on Monday, September 8, 2003. So it's the closest you can do from 20 years ago. The session chair was Louis Goubin. And I will use the slides from that time to go a little more technical. Okay, so in the first part, I will talk about the generic attack against any SPN structure, and only after I will talk about the case of the AES. We already talked about that. This slide, maybe I would not write it the same way today, because the way you induce fault evolved a little bit. This is important. This is about the fault model. So we are exporting faults occurring on bytes, random faults, and we assume that one unique fault occurs during the computation of faulty ciphertext. Finally, our attack can apply to any cipher with an SPN structure. I remind shortly of what an SPN structure is. So each round is made out of key addition, linear diffusion layer, and an S-box layer. Here we have the last 2.5 rounds of an SPN, and we will exploit faults on bytes that occur somewhere in the word frame. So the attack relies on the observation that the difference between correct state and the faulty state caused by one fault can take only a limited number of values because of the fault model. And after the diffusion layer, we still have the same number of possibilities because of linearity, but now the difference is spread out on many bytes because of diffusion. So I will present the first sketch of attack. It's not really an attack because it's not practical, but it gives an idea. So first we compute once and for all a list of all possible differences that could have been caused by a fault, and we will use this list as to discriminate key candidates. That is, we will consider every possible value of the last drawn key. It's here that it's not practical. Use it to decrypt until the last, just before the last S-box layer, and see if the difference we obtain could have been caused by a fault. That is, see if it's in the list. If it's not in the list, it means the key guess is wrong. So we obtain a list of possible candidates for the last round key. If the list is too long, we begin again with a new pair, correct ciphertext, faulty ciphertext. So you can, it's possible to prove an experiment that using this method, two faulty ciphertext with the corresponding right ciphertext are enough to retrieve, to have only a few candidates for the last drawn key. But as I said, it's not practical. So the idea of a practical attack is that we begin with applying the attack I described, but in the first time we limit ourselves to the two leftmost bytes of the last drawn key. Again, we compute a list of candidates, and after that, we consider each candidate in the list and we try to extend it by 1 byte. So considering here every possible value for the third key byte, checking using the list of difference, and so on. We refresh the list of candidates, and we keep extending candidates until they reach full length. And again, with only two faulty ciphertexts, we are left with only a few key candidates. Okay. So the AES, I guess almost everyone know how the AES works. Here I have pictured the diffusion layer, which is actually made out of the application of 4 parallel transformation, which apply 4 bytes of the same color on the picture to 4 bytes. So if we try to apply the attack I described on SPN to the AES, what we can see is that because of the non-optimal character of the AES diffusion layer, with 1 fault, we can obtain information about only 32 key bits. And with 2 faults occurring on bytes of the same color, we can retrieve 32 key bits. So with the basic attack, we need 6 faults to retrieve the key, because then we are left with 32 bits that you can exhaustive search. But it's possible to do better. What you can do is considering a fault occurring 1 round before. This fault will produce a difference on 4 different bytes the round after. And these 4 bytes are related to 4 different parts of the last round key, which means you can use these 4 bytes for the difference to just like if they were 4 different folds. So one fold above is kind of equivalent to do simultaneously 4 folds the round after. And so with this trick, you can, with only 2 pairs C star, I implemented the attack on a PC at the time. With only 2 pairs, you can always retrieve the whole key in a few seconds. Also, what I did not detail, but is that you can deal with faults occurring at other places before in the cipher, and it's possible to show that you can discard these faults that are not well timed. Okay. So now back to today. When a paper is cited a lot, like this one, it might be because it's really good, but it might also be because, as Amir said, it can be improved in a lot of ways. So I will try to answer the question, how can we improve this paper? There are several ways. First, I must say that in the previous presentation, I was a bit too modest because I told that the data complexity is that you need 2 pairs correct ciphertext, faulty ciphertext, but actually 1 is enough. Simply, if you have only 1 pair, you are left with 2 to 40 key candidates, and you have to do exhaustive search to find the correct key. So obviously, you cannot improve the data complexity, but maybe the time complexity could be improved. That's a first way you can improve the attack. Another way is maybe you can try to exploit faults occurring before the rounds we considered. This is important as well because the rounds that can be attacked are also the rounds that need to be protected. Finally, about the fault model, our fault model is pretty realistic because we are considering random byte faults. But one question is, could we get rid of the correct ciphertext? This could be important in some case because in some context, maybe you could not access to the correct ciphertext. Think, for example, to a counter mode of operation of which the attacker does not has control on the counter. So in the following, I will cite a lot of papers. It's my turn. By the way, I did not try at all to be exhaustive. So if you did an excellent paper on fault attacks on the AES and I did not cite it, don't yell at me, sorry. So regarding data and time complexity, there were actually a few papers dealing with this problem, and the best one goes as low as having only 2 to the 8 remaining key candidates, just with 1 only ciphertext pair. Regarding attacking the inner rounds, there is a nice paper in CHES 2011 that exploits faults occurring just 1 round before our attack. You can see from the title of the paper that the more deep you go inside the cipher for the fault, the more you have to use techniques from classical block cipher cryptanalysis, meet in the middle attacks, impossible differential cell attacks. But going that deep as a cost, because it has a cost in terms of data complexity. We see 1,000-fold, or a cost in the fault model. Finally, regarding non-differential fault attacks, it's possible. Again, it has a cost in terms of fault model. You can the random perturbation in one byte is not possible anymore. But we can see that there are results. We have here a paper in FTTC, and more recently there is a persistent tendency in CHES to have paper about persistent fault analysis. So this concludes my talk. Once again, it's a great honor. It matters to me, so thank you again.
So, and now we have the Rump session. So let me introduce you the Rump session chairs, Guido Bertoni and Francesco Regazzoni. My favorite one.
Thanks, Martin.
Hello? Yes, it works. So welcome to the Rump session. First of all, I want to say thanks to Gilles Piret, because after 20 years, he remains about a useful comment in a review. That is already something. Okay, so the first talk is about the
rules.
Yeah.
Silent, please. Silent, please.
What?
Silenzio, prego.
No, let them speak. That's okay. The Rump session is for noise. So, welcome to the Rump session. The first thing that I have to do is a test to see if I'm good enough to do the Rump session. So, Martin, is it good enough? Stretch, prst, crust, crook.
Stretch, prst, crust, crook. It is the whole sentence in Czech language, and it actually means push the finger through the throat, like this. In other words, start vomiting. And what is nice that there is no vowel there. Yeah, so there is no A, E, I, O, something like that. There are only R, L, and L's inside, because it is possible in the Czech language that every syllable can have either vowel or R or L. So we have such syllables that have only R and L inside. So it's okay.
Thanks. He was something that was Martin was teaching to me when we were in Bochum together. I still remember. Second, I want to annoy my co-chair, and I was thinking, what can I do to annoy him? And found a solution. You're gonna see this for the rest of the evening. And yes, the one of Ronaldo was there.
Next week, we have the derby.
Yeah, take it away. Yes, I know. I'm used to, but last year was different. And the third, the rules. So how to stop people. We were thinking what could be something. Among the things, there was a possibility to ask Martin to speak on Skype, but that would be too loud. So we have this mind loss function. So these tools, if you finish your time, we try to create noise and you should help us. And then I'll let you introduce the first talk.
Ladies and gentlemen, program chairs, Diego and Marcel, welcome on stage.
Hi everyone, I'm Diego Aranha.
Hello, I'm Hassan Medved.
And we are
Andrew
the
Guerrero.
program chairs. Come on. Okay, again. Hi everyone, I'm Diego Aranha,
I'm Hassan Medved.
and we are the program chairs.
Chairs.
Let's see how to price this. So we start with the program chair report, right? So it's a transparency report about the review process. Let's see if I can get this. Maybe not. Thank you. Yeah, that was quick, but not very transparent. Okay. So for the this edition of CHES, we follow the process, the reviewing process that has been established already, right? So the 4 submission deadlines, we have at least 4 reviews per paper. So PC papers typically have 4 reviews because they should be reviewed more rigorously. We have a rebuttal phase, we have a pre-rebuttal discussion, a post-rebuttal discussion. The idea of the rebuttal phase is, of course, to react to the reviewers, for the authors to pinpoint misunderstandings and then get them clarified. So we also, for the papers that didn't converge, our discussion phase was essentially decision-oriented. We tried to be pragmatic. We still had a few papers that were left undecided at the end. For those, we had online PC meetings, which are not very easy to organize with people spread around the globe. So only 3% needed those, but yeah, they were effective to actually reach decisions. So this is essentially the process. How can I go back now? It was supposed to be, how can I go back? Is the other button, yeah? I don't know how they give me this job, yeah? So then this is essentially the reviewing process that Thomas and Sonia had implemented, but we still had some additions for this year. So in particular, we clarified some of the outcomes and we made some of the requirements to be stricter. So in a sense, we crystallized and changed a bit how it's the operation of the reviewing process that they had. I like to say that they wrote the source code and we wrote the documentation. So one thing we also did was relaxing the affiliation restriction. So now we have up to 3 PC members for the same affiliation, just because the PC grew, right? The program committee grew to accommodate more submissions. We also broadened the CFP to include privacy preserving technologies. You see that there are references to MPC, FAG, and zero knowledge in the CFP. So in terms of forming the PC, these are the numbers, right? The challenge here, of course, is to have a PC that's a balance in terms of gender, background, the geographic distribution, and so on. We did that task by following the recommendations in the FAQ and the rules in the FAQ. In particular, we enforce the recommendation of not having a PC member to serve too many years, and also to limit the number of new members to 50%. So you have like a constant fraction of fresh members joining in to avoid biasing and also to give people a break. So you can see the numbers there. In particular for the MPC part, where we didn't have a guarantee that we would receive papers on multi-party computation, we had an interesting idea of having them only review papers if they were submitted, which was effective to not overload them with reviews that maybe they wouldn't want to do. Maybe that's a hint for people, for conference organizers trying to reach new areas that are a bit harder to recruit PC members for. So another addition we had was boosting the PC halfway through. So after issue 2, we noticed that the submissions were growing, of course. So then we decided to recruit more PC members. So then it grew from 65 to 71 members in total, which was good for managing the load, but actually a bit bad for the balance, because then we didn't have as much time to balance across all requirements, and we could have done a better job at that. But the final numbers are not too bad. So in total, we received 300 submissions exactly. I don't know why, but yeah, it was exactly that. So 67 of those were resubmissions, 81 long papers, 74 were PC papers. I consider that we consider that 4 of these submissions were really on the new topics. There were several submissions that were overlapping between CHES topics and the new topics we included in the CFP, but 4 of them were really maybe have been submitted not to CHES if we didn't broaden the CFP topics, I would say. In total, 1,248 reviews were written, of which 82 were external. Most of them were in the issue 4, because it's when the number of submissions typically grows, and then we allow sub-reviewers with more frequency. We didn't have a single desk rejection because papers didn't adhere to the requirements in the CFP, but we gave chances for the authors to fix those submissions, especially the minor things like forgetting the justification letter or having appendixes after the references, the basic typesetting things that can be fixed quickly. And we had around 20% of the submissions offending those requirements. As an author, if you can do just this absolute better job next time for the next chairs to check this before submission, it saves a bit of time later on. Those were the submissions. Let's see now what the consequences were. We had estimated 76 one-hour meetings, the two of us, to discuss, submissions, reviews, whatever, everything that needs to be discussed. So multiply 76 by 2 by 1 hour. That's how much time we spend across 18 months around. We also exchanged an estimated 10,000 emails. That's 1.2 gigabytes. Not just the two of us, but also sending automated emails to authors and invitations, everything you can imagine. That's what my Outlook, at least, folder shows. So then that's what costs to organize CHES, right? 2 times 76 hours plus 1 gigabytes of emails. With images or without images? Without images. This is just, I think, text. We didn't send many images, right? Memes are not allowed in these discussions. Other surprises we had were, we had one self-invited keynote speaker who wanted. And the funny part is that actually the keynote speaker didn't self-invite. His automated assistant sent a message to us inviting him. I found that original in a way. And we also had at least one person asking, I want to speak at this conference, I don't know what to do. And the answer was, you should submit a paper.
Okay, let's get to the numbers. Start with something easy. In total, we had this year 300 submissions, as Diego already said. If you subtract from that the resubmissions, you end up at 233. So that's an increase over the last years. That's good. If you look at the accepted papers, it's slightly stagnating. But if you look at the overall acceptance rate, it's declining, but still within the bounds. So nothing unnatural. Then let's look at we will discuss all these numbers in detail. But first, let me explain what the different outcomes are for those who are not familiar with the review process. So you have 5 outcomes: accept, that's no questions asked, everybody's happy. Minor revisions, when you have a shepherding process to implement some minor requirements, usually editorial, adding information, but not doing extra experiments. Then you have major revision, that's a rejection, but there is a clear path to acceptance. And then the reviewers have to write down a clear set of requirements. And if the authors implement that, it's usually an accept. And they should resubmit during the next or next +1 issue. And then finally, you have reject and resubmit. That's when there is no clear path. There is a good idea behind it, but the execution of the paper is somehow flawed. So then the authors are advised to not submit to the next submission deadline, but to give it some more time. Reject is clear. So good, let's look at the numbers. What we can clearly see here is, and the most important observation is that issue 4 is a pain for the reviewers. And you should really try to help to solve this issue. Consider submitting earlier. There are 2 more chances this year for this. The first deadline already passed. Or try to join the PC. Then to reduce the load. Then let's see at the flow, inflow and outflow. What you can see here is that if you submit a new paper, so a paper for the first time, it's very hard to get a straight accept. So that's a very small fraction. There is some chance to get a minor revision, then you're in. But most of the papers go to either revision or to reject. But most of the papers go to revision. And that's a good thing because it improves the quality of the paper. And also, once you have a major revision submission, it's the MRS, then you have a very high chance of getting in. And even for the reject and resubmit, there is also still a high chance. And also, even the best paper was a resubmission. So it improves the quality, or really it's good papers. So then let's look at the acceptance rates. As you can see, for major revision, you're almost in. So if you get a major revision, that's a good thing. Reject and resubmit, that's a slightly biased coin flip. For a new one, it's a bit hard. Long papers also have a high chance of getting in, but that's because most of the resubmissions become long papers. And I told you before, you might consider joining the PC. You have another reason here. Good. So those were the hard facts. Then Diego and I also sat together and thought, okay, we have all this data in the submission system. You not only have the papers itself, the number of authors, title, abstract, but you also get the suitability for CHES. You get whether it should be considered the best paper. All these informations, you get the number of conflicts with the PC, and you also get the bidding information. That means when the TPC sees the list of papers, they assign a number between -100 and 100, which indicates that they either want to completely avoid the paper or they want to badly review it. And we get all this information. So we took all this information and we basically correlated it with the average score of the paper after the process. Now, you see there are some good things that can happen, or some good indicators, and then some negative indicators. All of this has a logical explanation, but let's just forget about that. What you can see is there are some plausible things. Of course, if you correlate the average score with the average score, you get 1. That's very assuring. Then it also correlates with the outcome, also very assuring. Then novelty is good for CHES. If it's a resubmission, we already saw that. Then you have a higher chance of getting in. Editorial quality and long paper, we also explained that already. Then there are some things that have less impact, like, of course, number of PC conflicts, title length, and so on. But there are also negative contributors. So if you write comments to editors-in-chief, you usually need to do this if you have a resubmission. That means if you do this, although you don't need to do it, then it's even worse, so don't do it. Then the sum of preferences, that's basically the bidding I explained before. If a paper on average has more people that want to review it, then that's a slightly bad thing. Then the average reviewer experience, if you have many reviewers that are highly experienced in the field, that's also bad luck for you. Then the squared sum of all preferences, what does that mean? Basically, it means if your paper produces strong opinions based on the title and the abstract already, that's a bad thing. And then the top 3, average of reviewer preferences. It's basically those people who get to review the paper, how did they do in the bidding? And if they really wanted to have the paper and they get it, also bad luck. Then finally, the suitability for CHES, not a good thing. And yeah, if you manage that your paper is voted for the best paper by somebody, you also have a higher chance of being rejected. So if you want to have a paper accepted at CHES, write a nice, well-written novel paper, clear, but which does not attract strong opinions during the bidding phase based on the title and the abstract. So keep a low profile. Which is not suitable for CHES, and by no means makes a reviewer think that it should be the best paper. And then finally, we have some advice to the next CHES, because we saw the acceptance rate declining. If you want an overall high acceptance rate, don't assign reviewers papers that they actually want to review.
There's one more, there's more. Yeah.
Of course, the observations about being a potential best paper do not apply for the best paper. It wasn't rejected. So you've seen the program, enjoyed part of the program already. You have 78 papers accepted, 1 best paper that we presented on Wednesday morning. 77, the other papers are presented with 20-minute presentations plus 5-minute Q&A slots. You have 2 tracks, of course, in 2 locations, 6 of which were presented online. Today, I think all of those were pre-recorded videos. We'll try to have live presentations for the next days. 2 invited talks. Today was Peter Schwab. Thomas speaks tomorrow morning at 10, so be there. There are plenty of other events going, right? Many of you saw the tutorials already, so I don't have to talk about this. There was Taser on Sunday too. And we are here, right? During the Rump session after the test of time ceremony. So closing remarks is we want to thank the community. CHES is not a child anymore. It's 25 years old, right? but only managed to be a somewhat functional adult by a village raising it, right, to that point. So that takes a lot of effort by many people. With just two of them here as program committee chairs, but there is the program committee members, all the external reviewers, the managing editor, this team who might be in the audience, that's web chair, that's Ruben Niederhagen, who is in Taiwan, who couldn't come, the general chairs, the steering committee, the tutorial speakers, poster chair, the poster submitters, session chairs. Thank you very much for all your service. The artifact evaluation committee that will be discussed later, all the authors and all the speakers. And in particular, we would like to recognize and thank the support of our corresponding significant authors, because it's actually their birthdays this week, and we cannot be with them because we are here. Thank you very much.
Thank you. Next is Benedict. Hello, hello. Good evening. I don't have slides, so I have one less issue to deal with. You guys just did a fantastic job in explaining how much work it is, to get all these submissions in, kind of dictate a zoo of, scientists to do reviews on time and, discuss and come to agreements and make decisions and so on. You had already listed all the people who are involved, and you gave all the numbers, so I don't have to do that. Thank you very much for that. So I would like to ask again a warm round of applause for the dictators, but also the zoo, the external WS, everybody involved in the process. And now that once I'm standing here, I would also like to ask Hannah and Martin to come up to me, because there's two parts in organizing CHES, right? So there's all over the year, quite invisible for most of you, the submissions, reviews, and so on, all of this kind of stuff going on. But I had the pleasure of also doing their job last year. So now I really know, together with Svetla, what I'm talking about. Yeah, so there's another invisible, very, very long path that you have to walk to get all of this organized and lined up and make sure that everything works and that everybody will be happy, that there will be enough beer on stage, and that everything goes well. So there's a lot of work, and I know they spend a lot of sweat and tears on for it. So thank you very much for the organization. Ladies first, ladies first, sorry.
I just want to say that I counted my emails on Thursday morning, and it was 4,786 in that time. So,
Okay, so the next one is Peter. Thank you, Peter. Here we talk about the artifact.
No, this is here. Missing something else. Benedict? Good. No, it's all good. Perfect. So, yeah, it's great to stand here again at the end of the day. And well, several people already mentioned artifact evaluation before, and I have the pleasure to actually say something about the artifact evaluation at CHES and CHES 2023. So if you're wondering what the whole thing is about, it's a process that we started in 2021. And at the time, really, Douglas Debila did an absolutely amazing job at setting this up. And only this year, when I was artifact evaluation chair, I realized how much work he actually put into it and how well he documented all the things that you need to do to get artifacts online and the whole thing. So this is really amazing work that Douglas did. It continued in 2022. Martin Albrecht took over and also did a great job. And maybe you remember that last year, unfortunately, Martin couldn't give the talk, so I had to give the talk. And I was joking last year that how you get this job of a artifact evaluation chair is while you first get invited to the program committee, then you get uninvited from the program committee.
and then you're being told that the job of artifact evaluation share is still available. So that's what happened last year to me. Now this year, what I learned, last week I met the artifact evaluation chair for next year, which is Markus Saarinen. And he told, as I walked up to him, I said, so I heard you're taking over the job of artifact evaluation chair. He told me, yeah, I also just learned about it last week from the call for papers. I was like, so, okay, there seems to be really different protocols, how you become artifact evaluation chair. But yeah, so Markus is going to take over next year, and I'm sure he's going to do a really great job, because I told him everything he needs to do, because he had no clue. But actually, at CHES, we're trendsetters within the ISDR. And really cool, what I think, is that Eurocrypt next year is also going to do artifact evaluation for the first time. And so Martin, who did it last year for CHES, is going to take over and do it for Eurocrypt. I think it's really nice to see that as a CHES community, we established it, and it's now sort of moving further in within the ISDR and also making it to one of the flagship conferences. So the way that it works is that for all of the accepted papers, we invite authors to also submit an artifact, which could be program code, it could be a hardware implementation, could be a data set. And then those get evaluated by the Artifact Evaluation Committee for functionality and reusability. So basically, can you build the software? Can you run the software? Does it feel like maybe you can still build it a year from now, or maybe 5 years from now? We do not try to reproduce the scientific results of the paper, because, well, first of all, that would be potentially quite a lot of work. But also, if the artifact evaluation fails to do this, then what would that mean for the already accepted paper? This would be all kind of complicated. What we want is that, in principle, we want the quality to be good enough that people could, in principle, try to reproduce the results. And this is the way that we do this. We have a non-anonymous submission system in a hot crap instance. So the artifacts must include a README and license. They get reviews by at least 3 anonymous artifact evaluation committee members. So because the papers are already accepted and are usually already online, there's no point in, well, making the artifact evaluation from the author, like the authors, anonymous. But we do keep the reviewers anonymous, although the idea is that everything gets accepted eventually, but possibly through an iterative process where we improve things. And quite often it's just the case that artifacts may work for the authors, but they don't work for the evaluators. And this is simply, if you run stuff on a few different systems, then you just notice more and more things. We had one artifact this year which worked just fine for the authors and worked for none of the reviewers. And in the end, what turned out is that it works with some USB cables, and with some USB cables, it doesn't work. So, I mean, this is not something that, well, you know, if something works, you don't try at home, well, let's see if it also works with another 5 USB cables, right? So this kind of issues we really find in this. Possibly we assign a shepherd. So if it seems like there's more interaction needed, then one of the reviewers takes over and does this. And yeah, the goal is essentially to accept everything, just to increase the value of the paper by saying, well, the material that you need to actually build on the paper and to reproduce the results is all available. The artifacts are all on artifacts.isdr.org. And then there is a link from the paper page to the artifact. Now, for 2023, that has not all happened yet, and that is, I'm the one to blame here. So I did it. So most of the accepted artifacts are online, not all of them yet. Maybe through the week, I'll get the remaining ones online. I think for one of them, I'm still missing the copyright form. You know, it's a bit of a process. And the backlinking has also not happened. So once I have everything online, I'll ask Tim and Markus to take care of that. But that's gonna be the case. So basically, the spirit of the whole thing is very nicely summarized in this quote from the call for artifacts. Just imagine you're a first-year grad student in 2029 who's told by their supervisor, see if you can change this artifact from CHES 2022, 2023 to do X. Then we want to give them the best chance of success with the least amount of pain. So that's basically what we're trying to do here. For details, you can just look at that link, what the whole artifact evaluation entails. Now, as authors, you might ask, my paper's already accepted, why would I spend even more time on submitting an artifact? I gave one answer last year because I had to step in for Martin. I'm going to give another answer this year. So the point is that everybody writes papers, and you need to have some way to stand out, to build a career. And I believe you have exactly 2 ways to build a career in cryptography. So either you give brilliantly funny Rump session presentations or artifacts. I believe the only reason that some people in the community know me is because of my Rump session talk at Eurocrypt 2009, where we went with guitars on stage and stuff like that. So
sorry. You can do both, huh? You can do both. So
You can do both.
Okay,
Yeah, you can
thank you,
absolutely
thank you.
do both. No problem. But like, look through the remaining the talks in this Rump session. Think about which ones are really, really brilliantly funny. If they're not, artifact, right? This is where you want to go. Okay, so there was great work in the artifact evaluation. I would really like to thank all of the people on this evaluation committee. So it's mostly junior people, PhD students, postdocs in the community, not all of them. And I think it's a great way for young people in the community to get involved, to understand a bit how reviewing works. The load is very little, so everyone got almost all deadlines, at most one artifact to review. So you can really spend the time and see how it works. And yeah, so thank you to all of these people. So just some statistics. It was very, very different how many artifacts we got. So we got 3 in the first deadline, then we got 6, then we got 9, and the last one we got 4. They're still, so the process for the last one is still ongoing. It's just that the artifact evaluation deadline is, well, sometime after the paper, the camera ready deadline. And that's also during holiday season. So getting all those reviews and then the iterative process done is actually quite tight with CHES. Next year, CHES is a bit earlier, so it's going to be even tighter. So let's see how Marco is going to get this done. But essentially what we saw, so last year it was about 30% of CHES papers that came with an artifact. This year it's 28. We'll still see, let's try to pump up those numbers. But I think it's also quite nice, like to see slightly below 1/3 of the papers. I mean, this is not bad, right? All right, so then the last thing that I have to do, it's actually the nicest thing of this talk, is to hand out the Best Artifact Award. And while the Best Paper Award is known before the conference, the Best Artifact Award is actually a surprise. So that's quite nice. So let me start with the runners-up. We actually had a process within the committee to vote, and there was it was pretty close call in the end. There were 3 papers or 3 artifacts that were the runners-up. So that is the paper by Giovanni Camurati, Matteo Dall'Amico, and François-Xavier Snodart on MacRank, Ira Dushar, Valerie Tepper, Vadim Bugaenko, Oleg Karav, should have practiced those names, right? Karavaev, Leonid Azriel, and Yuri Kreimer on carry-based differential power analysis, and then Yannick Zeichner, Nikolai Müller, and Amir Moradi on ProLead SV. So those are the runners-up. And the winner is the paper on the PLL TRNG by Maciej. Oh, this is a tough name to pronounce. Can you help me here? Maciej Skorsky, Quentin Dallison, Nathalie Bouchard, Florent Bernard, and Victor Fischer on enhancing the quality and security of the PLL TRNG. So, the authors of that paper that are here in the room, could I ask them to come up? Hopefully there are actually any authors in the room. I did not prepare that before. First of all, I should tell you, your artifact is accepted. That was actually one of the last 4, and I did not mark it as accept yet because I thought it's a nicer surprise. None of them is here in the room. They're all at the bar. Speaks. Victor, are you around? All right. I think at some point my time here is running out. I can wait for a short moment as maybe Victor is walking in. By the way, if you're wondering why we have exactly 1 hour before the break and exactly 1 hour after the break, this is because I put the program for the Rump session online and the Italian chairs did not give me any times.
There is no time in Italy.
Come on, we are Italian. Come on, have fun.
All right, so I guess I'm not going to get rid of these nice award things here. So we have to do that some other time. Probably when the paper is being presented, we'll try again and hand out the Best Artifact Award. So thank you again, and please submit our artifacts next year to CHES.
It's an honor for me now inviting to the stage the founding fathers of CHES, Chetin, Christoph, and Jean-Jacques. The journey started 25 years ago, and we are here today thanks to them. Let's make a big applause for thanking them.
Yeah, so thank you so much. It's Jean-Jacques, Chetin, and me. Yeah. And yeah, so we were asked on relatively short notice to present in a halfway entertaining way what has happened the last 25 years. So yeah. Okay, so what you can see here is actually the very first CHES conference. Anybody recognize this young man here? It's Adi Shamir, yeah. Okay, so this was really good. But what's the first talk? Yeah, yeah. But before we go into details, we still, you know, with the engineers, right? When we started, we were like fighting the mathematicians at crypto, right? We still can't do the math because CHES is only 24 years old, right? So this is CHES 25, but it's only 24 years. So this is, yeah. So maybe let's start. It was really, yeah. Chetin and I, we were doing research before, right? I think. Yeah.
Not before, no. Suddenly, you sent me an email.
Right. Yeah. Yeah. So there were very few. We thought very few people were doing crypto implementation. I think actually, Chetin, you.
I should give you a few words then. Some of you, not any of you, but some of you here should remember RSA conference. Do you?
Yeah. Still around. Yeah.
Yeah, RSA conference that also had an RSA seminar, and I was very much involved with Kurt Kaluski and Ron Rivas doing that, and started writing tutorials on RSA hardware and RSA software.
The microphone.
Yeah. You have to come closer.
Yeah. So I think at least the story of my part. Thank you. The story of my part started with RSA, being a member of that lab, working with Rivas, Tahir Al-Gamal, and most importantly, Jim Bitsos, the guy who made $500 million from the work that you guys or younger, older versions of you did. And so I started doing that, and suddenly after 3, 4, 5 years, Christoph contacted. He said, and he was doing this work at Essen and then later at WPI. And we started communicating. Yeah. And it was a lot that Christoph's idea, even though I had a visibility, like Bart Prenell knew me who I was. And Jean-Jacques would come also the RSA conferences, RSA seminars.
Yeah. Yeah, so it was so we were in touch. We were on the opposite side of the coast. So I was on the East Coast in Massachusetts. You were in Oregon back then. Yeah. And I contacted him, and your papers went way back, right? You started in 1980s, right? At some point.
Yeah, 80. No, 88.
88. Yeah. So then I started doing this stuff in 95. So it was this crazy idea, and actually I had reached out to other people. Let's do this applied crypto conference, and all the other people said, this is stupid. Who needs that, right?
No, but it actually was very smart because our papers didn't get accepted by crypto. So we had our own conference. That's how you were born.
So yeah, and then so it's actually an interesting story how CHES got its name. So back then we had email already, right? So that was like pretty early on. So and that was a email that I wrote to Chetin in November 1998, so a long time ago, right? And this was how we did web pages back then, right? That was my personal web page.
Yeah. Look at my email address.
Where is it? Yeah.
You have your microphone, you can use it.
So this is really cool. Over there, yeah. And then the first idea, let's call that CHE, which is cryptographic hardware and embedded systems.
That wouldn't have worked.
Right. And I had a PhD student, Jorge, I don't think Jorge is here, Guayaro, he said you can't do that, right? Sounds too much like Che Guevara, right? And then we both had the brilliant idea, let's call that CHES workshop. Great idea by Chetin. So then, okay, we can do that. And then our third trial was, why don't we call that CHES? right? Which is short for cryptographic and embedded system. And we thought, sounds good, right?
Yeah. Yeah. Excellent. Yeah.
Yeah. So and that is how you advertised conferences back then. You had like a hand curated mailing list, right? That's what you did. There was no Twitter, there was no X, there was no Facebook, right? And you know, this, you see, it's not centered because I did that by hand, right? You know, you put blanks in here, right? That's why it looks stupid, right?
It's not even HTTPS.
Right. Whatever, yeah.
We're supposed to be cryptographers.
Yeah. So that was the mailing list that you maintained, right? Apparently, right?
Yeah.
Yeah. So that's how it started, and now we are not kidding. So we thought if you get 50 people, it's great, and we get like 60 or 70, that will be a huge success, right?
True.
That's what we assumed, right? And this was the first program committee, and there are very few people that are still active. Jean-Jacques was there. Bert Kaliski, Ernie Brickell. So there were mainly people from the crypto community. Victor Schub, right, who is a very famous theory guy. Michael Wiener, Christoph Muland. Yeah. But we were really, really lucky, I have to say, because you got a right. Maybe you can talk about Brian a little bit, right? Yeah.
Look at the color of my hair.
Yeah.
My head is all hair. Not anymore. So this guy, he was an NSA director among us, and he was very supportive. In fact, they always want to be there, you know, looking at you, sort of. You know. But actually, the crypto fight was over already, because Al Gore made crypto commerce matter rather than national whatever security issue. So it was pretty good still having him there.
And back then it was still, at least I was a little bit wondering, you know, that crypto existed as a conference, crypto and Eurocrypt, but this was more or less theory they were doing, right?
Yeah.
And we were a little bit wondering how NSA and the US government were thinking about a hardware conference, right? Whether we would talk about secret stuff, and I think that was a great endorsement, right? That an NSA guy, right?
Not because we have thought of it, but you know, later it was understood to be.
Yeah. So the other really, where we were incredibly lucky, you know, this was a new conferences back then. Conference didn't happen as often as they do now, that people propose new conferences. Guess who submitted a paper ADI, right? On who has heard about the Twinkle device? Okay, so this is homework for all the other ones here in the room, right?
Yeah.
Yeah, so it was an optical computer, was a proposal for an optical computer that you could use for factorization.
1024-bit number.
Right, yeah.
Not just any number.
And there was actually CHES made it into the New York Times because of Adi's contribution here. And this was great, and I think we can really, I really honor Adi for that. You know, he's this world famous cryptography, this crazy conference by Chetin and me, and he probably barely knew us, probably didn't know us. And he said, sounds cool, why don't I submit a paper? And of course, that was the first paper in the workshop, so everybody saw Adi's name. And long story made short, instead of 50 or 60 or 70 people, we got 160 people. So that was, wow, you know. And back then, again, there was only crypto and Eurocrypt, but they were small too, right? They had maybe 250 people or so, crypto and Eurocrypt back then.
No.
In 2000, maybe, crypto was 200. Yeah.
So we were not that much smaller than crypto and Eurocrypt, and that was the gold standard, right? Everybody was looking up to crypto, right?
Yes, exactly.
So that was really great, right? Here's the next CHES, and then I think another endorsement that we got, which really helped to grow CHES, was by David Nakash, right? Yeah. So he really helped us,
Maybe for the first CHES, we have to say that the first artifact
I still have one copy, but I didn't think of bringing one.
Let's change it.
Yeah, that's good. And also, until like 2 years ago, I had the T-shirts. Even the T-shirts were better back then, right? So the CHES 99 T-shirts. So that was really nice. He gave a talk how to explain side channel leakage to your kids, which was really great by David, right? He was head of Gem Plus research, which was again a really great endorsement for us. So So what happened after? The first two CHES, they were both in Worcester Polytechnic Institute, where I taught back then. It's a small technical college in Massachusetts, and we have a few people here from WPI. So the next one was in Paris, which was great. And that, again, that was a big jump for us, not only geographically, but, going to Europe. Then we went to San Francisco. You organized
Yeah,
that,
which is
right?
like RSA, same place where RSA conferences were. Yeah. Sofitel Hotel.
Yeah, and then you know what happened. You've seen that, right? This is the CHES starting page, right? And we went to, in the beginning, I think we alternated between Europe and the US, right? It was Cologne, Boston, then the UK. And then we went to Yokohama in 2006, which was also big, we thought it's a big risk, right? Should we go to Asia? Would we lose people? And it was a fantastic conference, I think, with many attendants. Right?
Between this CHES, at the beginning, you were the organizer, the general chair also. And after that, we asked me to enter into ASER.
Exactly.
And there, for that, you have to know the story. So at that time, I was a director of ASER. And so there was two meetings, one to present CHES, so we have to defend it, and another one for voting. And the story you have to know that is related to taxes. Really, the problem was the first meeting was in Aarhus for Eurokit, and my travel agency did an error because in Denmark they changed the names of the airport. So it's the Sunday, the meeting was Sunday. In the morning, I was not at Aarhus, but I was 200 kilometers from there. And the Sunday, there was no train, no plane, no flight. So the only solution was to go by taxi. So I called Christophe and I said, I have to go to a taxi for 200 kilometers. And you said, okay. So I was going there and I was just in time for the meeting, thanks to that. So otherwise, maybe there will be 1 year or more needed for that. Okay, so no problem. The voting was at the next meeting in UCSB, Santa Barbara, for crypto. And there, another problem, I was going to Los Angeles, and the flight was late. And again, I have to go by taxi. So 160 kilometers, I have to go. So the incorporation of CHES into ASER means 350 kilometers.
By taxi.
By taxi.
Yes,
Okay,
thank you very much. Yeah. So what happened then afterwards? So we want to talk a little bit now. Now it's pretty quick. Is like the evolution of CHES after the first few years, right? And there's the 3 stages of growing up. You're being a child, becoming a teenager, and eventually you try to be an adult. So in the first 2 years, it was essentially Chetin and I, we managed that, as we go together with the program chairs. And then in year 5, we founded our first steering committee. There was the 3 of us, and then Colin Walter and Bert Kaliski, who joined that, right? And also later on, Stefan Mangard and Benedikt Gierlich, they became head of the steering committee, and they put a lot of work in it. It's an incredible amount of work and very important. And we should also give a round of applause to Stefan and Benedikt. Yeah. Yeah. So that was the kids phase, and then we slowly became a teenager. And as Jean-Jacques said, we became part of ISCR, and I don't think Bart is here. But again, that was a big thing, and that was not against us, but there was there had been some resolution earlier that IRCR would be restricted to 3 conferences, Crypto, Eurocrypt, and Asia Crypt. So there was a big discussion, and I think we were the first one that were endorsed by IRCR. And then again, thanks to Jean-Jacques that he also did a lot of politics and got us into IRCR, which again was a great endorsement for us. And now the adult phase, that is more recently, 2 things happened. So first of all, we dropped the workshop name. We became a conference, right? Which is really great. We're really proud. Only a few years ago.
Plus, we also had first time, actually, not in 16, but 2010, co-located.
Oh, with crypto, yeah.
With crypto,
Yeah,
2010, 13, and 16.
In
3
Santa
times.
Barbara, right?
In Santa Barbara.
Yeah, yeah.
For the first one, you were program chair, general chair.
General chair.
Yeah.
And then you, exactly.
And then even more recently, and most people are aware of that, we switched into a journal model, which again, and the discussion had been going on in the steering committee for many, many years, and we couldn't make up our mind. And I do think we believe we followed the fast software encryption workshop or conference, because they did that and it was very successful. And I think everybody's happy with that now. So this is kind of part of growing up, I guess, right? 20 years later. You've seen these type of things, right? The CHES participation. Again, we started here with 160, and then now it's hovering around between 500 and 600, minus the pandemic, which is a very healthy number. So we're very happy with that. Another thing is conference ranking, and I Googled that for that talk, and it's all over. You get all kind of different results. So I settled with GS, which stands for Google Scholar, because they just do citation count, right? What is interesting, so these are the top 20 security conferences here. We are in a healthy middle place, number 11. And what is really interesting, again, when we started that, we were all looking up to Crypto and Eurocrypt. And they're pretty good, but they're not that much more often quoted than us. So I think this is something all 3 of us, we hadn't anticipated. So this is pretty good. And the last slide, I also wanted to look at, we had looked at the Test of Time Awards, but looking at a very widely used metric, namely Google Scholar. So I just did a search with what are the 3 mostly quoted papers. And number 1 is by Gandolfi, Moutel, and Olivier from 2001, electromagnetic analysis. So that has over 700,000 citations. So this is side channel attacks. The second one is a PAF one, which is another big topic, right, by Jorge Gallardo, Kumar, Schrein, and Tölz. About 1,500 citations, also very, very much, and it covers a very different area from PAFs. And then the third one, which is most citation, is Present by Bogdanov et al. With over 3,001. What I find interesting, first of all, you can write CHES papers that get a lot of citations. The other thing, they cover different areas of CHES, right? So we're not only side channel, we're not only crypto implementation, we're not only PAF, we're all of that. So I found it very interesting that these 3 papers are the most widely quoted one, and they are covering the whole CHES space. So I think that's a really nice statistic. It's the end of our presentation. Thank you so much.
We would like to thank our founding fathers for the opportunity to meet and to have more beer every year. So we prepared again some presents to remember Prague. So again, some pictures. Yeah. So
we were afraid that would happen.
So they all are the same.
Okay.
They are the same, but they are the different than before. So Jean-Jacques has 2 different pictures. Yeah. So
With the president.
Yeah.
Wow.
President.
Chetin?
for you.
Thanks very much.
Yeah. Oh, thank you so much.
Signed by Michel.
Yeah. One is for me. Okay. Can we take a picture of the 3 of us?
Yeah, I can.
Can somebody take a picture? And thank you so much, everybody.
So next is an update on the CHES challenge. Gaëtan Cassier and Charles Momin.
So it's a pleasure to give you some update on the CHES 2020 challenge, which is a search analysis challenge of a mask implementation of the AES. So today we'll explain a bit to you what the challenge was, some statistics a bit more tonight, and then finally we'll announce the winners of the challenge. We will make the honor of making some short presentation about the new discoveries and how to break mask side channel datasets in 2023. So the challenge is organized on behalf of Simple Crypto, which is a non-profit organization that aims to bridge academic research in physical security to academic practice and try to see how we can teach more into each other by the means of open source software and open source hardware. So the challenge, so if you remember in CHES 2022 last year, we announced the Simple Crypto Association. And then we say that, oh, we are preparing a masked AES at higher order. So then we took a side channel evaluation library and made a challenge for this year. So this Smash implementation, Simple Crypto masked AES in hardware, that's a masked hardware IP that's completely generic, can be implemented on ASIC or FPGA, currently mainly FPGA validated. It's based on composable masking scheme. It's probably secure, and we include a nice Trivium PRNG. So that's all a nice package that should be easy to instantiate. So yeah, it comes on GitHub, fully open hardware. There is a bunch of documentation, so probably you should be able to understand how it works, and you have also some preliminary security evaluation online. But since tonight, you will have much more thanks to the result of the CHES challenge. So see our website for more. And I will leave the floor to Charles for how the challenge went.
Okay, so basically, thank you. So basically, what is represented on the slides for the moment is the general tool flow that were used during the challenge running. And you have three main boxes on which you should focus. Basically, which the one in orange is the fact that we have built, in fact, data sets out of our implementation that was instantiated on an Arctic 7 on the CW305 board. And the public data sets are, we have two public data sets, the training one, which has a variable key, and a validation one, which has a fixed key. The blue part is, in fact, the one that candidates that wanted to do a submission has to focus on, basically based on the open core and the fully Verilog description of the circuit. They were able, thanks to some tools, to perform intermediate value simulation and out of it build leakage model. And afterwards, we, in fact, provided a full framework which has a working submission. And they were able to try the submission on our evaluation setup in order to check if everything went well. And in green, it was in fact the evaluation part that was run in our server. And this evaluation part, so we were taking the attack submission that was submitted by the teams, and based on a third data set, which has also a fixed key but a private one, we evaluated the submission. And our evaluation was based on the key rank that was achieved by the attack submission. And at the beginning, we were not exactly sure which threshold to use for the key rank. So we had a quick look on the Bitcoin blockchain. And it appears that, in fact, at the time, this complexity was around 2 to the power 68 of hash per second. So we're like, okay, it seems like a good threshold. So we maybe will focus more on this new unit, the BTC-H. So we were speaking about that with other friends that were proposing to use maybe a new name, which starts with B and end with H. So that's maybe a bit hard. So we'll not say it today. But okay, anyway, we also add, you can pass. We also add a new target afterwards, which was on a Spartan 6 FPGA on a Sakura Gboard, and which has the particularity that the randomness for this dataset was not provided to the candidates. Okay, so out of this this challenge, we have some stats. We had 5 teams that participated, and I don't know if you know, but basically we also organized the CTF of CHES 20, and we had 0 submissions. For us, 5 submissions, 5 teams, sorry, it's already something. And it looks a bit like some achievement unlocked on our side. So we were quite happy about these 5 teams participating. So in total, we had 112 submissions, which is quite cool too. And you can see on the figure here the leaderboard that was in fact, so you have 2 types of targets. So you have the dots that are successful attacks on the Arctic 7 target, and crosses that are a successful attack on the Spartan 6 target. And you see that in fact 2 teams managed to perform successful attack. Okay, 2 teams. We also reached some cool peak rates in terms of submission. So at some point we achieved 2 submissions per hour per team. So I have to apologize to my coworker because at some point it was a bit like a denial of service against our server. So sorry guys. And we had up to 12 submissions per day. So, okay, I said that 2 teams managed to break the data set. That's not exactly true. I don't know if you are following Ninja Lab on LinkedIn, but at some point they post this stuff. And it appeared that we, in fact, had a team that was performing a side channel attack against our evaluation system instead of the target. But I will not say anything more because we will have some information after. So maybe the stuff that you are waiting for. So we were giving prizes for most points and best attack against each target. And for that, we have the small, okay, perfect. So we have for the Arctic 7 target, Valence Christiani that has made the most points and the best attack also. Against the Spartan 6 target, the most points award is for Valence Christiani 2, and the best attack is for Thomas Marquet. And congratulations to both of them already, so you can give them a round of applause. And I also invite them here to present quickly their solution. So if they are here, they should be here because they have provided some slides. So. Thank you.
Thank you for the introduction. So I'm going to try to explain you how to smash the CHES challenge, but in 2 different perspectives, like from being honest to evil. So in life, you really have 2 options, and you can be on the good or the bad side. You have to find some balance. So yes, we're going to start with the good side. So if you're an honest guy, you could, just like any other side channel work, start to look for some leakage. And it's most likely going to happen around the first run S-box. But in this case, we are a bit unlucky that the S-box output doesn't leak that much because it's not even stored in a register. So you have to look actually inside of the S-box. And since it's a tower field implementation of the Xbox, which basically breaks down the S-box into hundreds of single bit level operation, you have a lot of intermediate variable that may leak information. And so if you're an honest guy who wants to actually use the maximum of information provided by this sensitive variable, you may try to actually build a huge graph representing the S-box computation from those equations, and then make a lot of Gaussian templates, more than 4,000, 1 for each node of the graph, actually 2 for each node, because the implementation is masked, and so you can template both of the shares. And then from this, you can apply the belief propagation algorithm using the Saska framework and recover the key. This is a good strategy. You can go as low as 290K traces. So this is quite good. but it has a couple of problems. First, it requires to understand a lot of theory about BP algorithm, about graph, about how do you deal with the loops inside the graph. And it's very long to train all those 4,000 templates. And it doesn't even guarantee you to win. Like at any point, I was watching like the leaderboard if someone have an improvement of 10% of my submission. So it's not very relaxing. So to actually be guaranteed to win, you have to come up with a zero trace attack. But to do this, you have to go on the other, on the dark side of the force. So you have to become a bad guy, and let's try to actually see how it comes. So we need to find another side channel leakage to actually extract some information on the key. Let's be honest, power leakage is a bit old school. So in this case, the leakage is going to happen from the evaluation framework itself. So actually, when you submit a submission, you have a response which says if it's successful or not, if you are behind the threshold of 68. And you also have this, you have the upper bound of the log 2 of the key rank, which may leak some information. And what I saw is that if you aggregate many information of well-crafted submissions, designed explicitly to recover some informations, you can extract enough information at some points to go for a zero trace attack. And you actually need to extract approximately 60 bits of information, because 128 minus 60, then you pass the threshold of 68. So how many submissions are required to do this? Well, it happened in, well, I did some local analysis, which reveals that the best way to actually extract some information would be to propose a uniform probability for all the bytes except one. And on this byte, use 266 value for all the values possible with a uniform spacing. And you can make a submission and try to obfuscate this to not be flagged as a suspicious team by, for example, obfuscated behind a neural network that would be trained to output a constant value, whatever the traces are. And then you can do that, upload the submission, and start all the log 2 of the key rank. And I did the information theory analysis, which reveals that doing that, you will gain in average 4.9 bits of information per submission, which is quite a lot. And if you make the computation, you can see that if you multiply this by 13, you go to 63.7, which is enough to get the threshold of 68. So actually, in average, this would require 13 submission. So let's do it. This is what I did. I created another account to not be flagged, which name is secartores, and which should be read backwards. And then I spaced the submission by approximately 2 days for each, so again, not being flagged. And I did not like do them in order. I went from the least leaking bytes to the most leaking bytes, because if at some points they were stopping the process, I would anyway have the information on the least leaking bytes. And I used as a reminder the first letter of the submission to know which byte is concerning in this submission. And after having all these 13 submission, I could run another local analysis, which states that I gained 66.1 bits of information, meaning that the log 2 key rank of the key of the final attack would be 61.9. So I aggregated all the results and mount the final attack and send it, and here we go. So I have actually one trace attack to not like make the script bugs, and it was exactly as planned, 61.9. So here's how you smash the smash challenge. Thank you very much.
Thanks for the talk. Congrats again for the contribution. I'd like to call Thomas Marquet for the other winner of the challenge.
Hello, everyone. So my name is Thomas Marquet, and I'm a PhD student that had something to prove. So I decided to enjoy some nice summer screen light. So the second dataset, the main problem was mostly that you had no access to the randomness. So this makes it very nice for deep learning. And so basically you had to choose the best intermediate so you could pray very well to the deep learning god so that it gives you a model that works quite well. So the intermediate targets are basically those 4 wires that have the nice property of leaking the Hamming distance. And for those who have a good vision, you can see there are zeros somewhere. So then the things that are on the left of the zeros basically are on the right. You can recover them with quite a good accuracy. The only problem is that on the left you have the round keys and it doesn't leak so well. So basically I went from the right to the left, and the bytes on the right are actually leaking extremely well, so you can consider them recovered. I'm not going to explain them. Basically, any good deep learning model would recover them because there are way too much traces for them. And then basically, I'm just trying to recover the 12 other bytes. So how do I do that? Well, tomorrow you are going to be lucky enough to have the explanation, basically, because there is a paper called Don't Learn What You Already Know by Loïc Mazur, tomorrow afternoon, I think, that will explain how to encode the masking scheme inside the neural network. And this makes a big difference in the, let's say, success rate of your neural networks. And in addition to that, I'm presenting you a very ugly model that I don't expect you to understand. It's a multitask learning model, so I'm trying to learn all bytes at the same time with the hope that basically, because I'm trying to learn all of them together, they are sharing features and it might be better. And actually, I showed in a reprint that multitask learning is significantly better than a single task. And I'm also presenting some complementary result to Loïc Mazur's paper to show that actually the hard encoding of the layers is extremely good. And finally, well, this looks less than ASCAD. Actually, the cross-entropy loss goes from most of the intermediates from 554.52 to 554.52. So the actual learning is in the floats, which are not shown in TensorFlow. So yeah, so I really encourage my fellow deep learning practitioner to move to something that is a little bit more challenging than ASCAD. Because in the end, for this, I have 900,000 traces, and ASCAD, I can get it in 1. And yes, and I thank the European Research Council for feeding me. Thank you.
Okay, so what's next? Basically, we are planning to publish the secret data set that we are using to evaluate the submission. And we will keep also a leaderboard with attacks that are the best in the literature against this data set, against SMASH. So
this means that the CHES challenge is over, but the SMASH challenge is not over. So if you'd like, please continue attacking, please continue smashing, and just submit a result to us. We'll be happy to feature you on this website and then let you know if we organize future official challenges.
And also don't hesitate to go back to see our new website because it's brand new and it's cool. So, yeah, if we have any question, don't hesitate to send us an email or just come after and let's grab a beer together. Thank you.
So we will now have a 5 minutes break, which means it's 9:30, no, 8:30. We will come back at 10 to 9.
Okay, welcome back. So in this second part, we have the most interesting speech. And after every speech, you can give more or less noise, depending if you like or you don't like. And we will take care about this because we have best Rump session presentation hour that will be given at the end of this session. So first is Victor on the evolution of passwordless solutions, a dystopian future. Welcome on stage. You ask for 5 minutes, you have 5 minutes.
Yeah.
Yes.
Hey, hello everybody. So yeah, up the remote, yeah. Just want to talk about a current trend in cybersecurity, something kind of serious, you know, passwordless solutions. Huh? So what is the root problem? Is like how a human can store a password or a cryptographic key without memorizing it. And that's like it's kind of the dream of any people in the cryptographic field. So let's explore some current and future solutions, as well as their attack surface. We are in CHES. So let's review some current technologies. So basically, you are all from the CHES community. The first thing which come in mind is like an embedded system with a secure element. And a good example is a FIDO2 hardware token. You plug your token, you get signed in on your Google account or so on. But what is the basic attack surface? It's the evil mail attack. So someone steal your device during a short time frame and is able to clone your device. Another attack surface is to lose your device, which can serialize as a self-denial of service. So another current, recent and current technology is an embedded system with a secure element and some biometrics. For instance, you have now a fancy credit card with a fingerprint sensor on it. So yeah, perhaps someone have this kind of credit card yet? No? Anyway. So what is the attack surface? It's the Computer Chaos Club attack. Perhaps you remember in 2014, a German hacker was able to steal from a picture of the former German Ministry of Defense and reproduce the fingerprint from a picture. Yeah, it becomes like, it's still non-invasive attack, but it becomes kind of a serious attack. Another more recent example is like to use ID and some biometrics. For instance,
Ledger, you know, this famous French company about cryptocurrency hardware wallets. They just launched a new service called Ledger Recover. And from your ID document and your Face ID, you can like kind of with some MPC and some trust in third parties, you can store in the cloud securely your seed phrase for your Bitcoin account and so on. But what is the attack surface in this case? Is this kind of famous attack from a Vietnamese cybersecurity company who were able to create 3D printed mask and were able to hack the iPhone X Face ID authentication system. So yeah, that's pretty nice attacks, but they are still non-invasive, okay? So now let's review the like kind of the future for potentially dystopian technologies about all these passwordless solutions. So something which exists since like let's say 5 years now, it's like using a contactless secure element and put it inside your body. So perhaps you know this US company, Dangerous Things. It's like it's a real company, it's a biohacking company. You can buy a kit with like a MyFair or you know kind of a secure element inside a capsule, and with a surgery kit, and you can put it in your hands. It's so yeah, it's like so yeah, you can lose any you always have your crypto key on yourself. So in this case, what is the attack surface? It's the on-cut attack. So it becomes like more invasive attack, and yeah. But I guess you are all aware about the new AI revolution. And probably you have heard about the WorldCoin project. This is this side project from Sam Altman, the CEO of OpenAI. And the idea is to use your iris to create a key, crypto key. And then you have like kind of an account on the WorldCoin blockchain. And then the AI machine will work for you and you will get some coins. So it's pretty cool. As a, why not like, so cool. I just have to open my eye and there's my crypto key. But I guess you all remember this movie. The attack surface is a Demolition Man movie attack. Perhaps you remember Wesley Snipes to escape from the jail using a pen from a guard to get the eye of the guard. So yeah, that becomes kind of okay. So what could be invented as a countermeasure against these dystopian technologies? An idea, you know? Anyway, just some advice from old school security experts. Use old school technologies because at least you keep safe your hands and your eyes.
Well done. Well done. Huh?
Next is Mark. We are on the clock. Again.
Hello, everyone. The title of this short presentation does not refer to the Rump session itself. It does refer to clock glitching. Yeah, clock glitching is something that people have been doing a lot 20 years ago, and at some point that was quite successful, but it was also a period that ended with the introduction of the PLLs. So many chips got a PLL. That meant that they would generate a clock internally, and if you would still have a glitch in your external clock, that would not get through the PLL, and glitching would be impossible. So people stopped doing that, but we kept being curious about that. And in the past 2 years, we realized that there's actually a forgotten attack window. When you start up a chip, it does not run immediately on the PLL. It will take about a millisecond. And this is a millisecond in which the chip starts its boot process and it reads its OTP registers. So these are the modern day fuses that have important information like restrictions for memory access. So there's a brief window of opportunity to attack and escalate privileges. So we made a small device that can do that, switch between two clocks There was quite some engineering doing that at sufficient high speeds, but it proved to work on several chips of today's technology. So clock glitching is back as an attack method. I wanted to make you aware of that. Thank you.
So next is Benedict. How to measure security?
Yes, so I'm taking a second shot. You remember Peter Schwabe saying earlier this evening, you want to be standing out from the crowd, you submit an artifact or you give a Rump session talk. I've never submitted an artifact so far, so I'm going to give a Rump session talk. And so the question is how to measure security, how to see about trends, what's happening, and so on. And so if you look for wisdom, then sometimes it's wise to look at what other people are doing. And I wanted to speak just about one page that was published this year in a booklet. And this booklet comes from the International Solid State Circuits Conference. That's like the circuits place to be. Like if you work in circuits and you want to publish, you want to be visible, that's the place where you want to publish. And this year was their 70th anniversary, and they published a booklet which had lots of papers inside, but it had also some kind of auxiliary information, which is not, let's say, really, the contents of a paper, but like, the bigger context of how things are going and so on. Do we have a pointer here in this thing? Okay. So, so I have to point here, of course. Yeah. So this is one page that was in this booklet, and so I just want to speak about these graphs here in the middle. So if you want to learn about trends, for example, in side channel security, it's actually super easy. These people give you the answer. Yeah, you just make a graph where you have here, years in which people publish papers, and you have here, for example, number of traces needed to break a certain device, and then you plug in a couple of data points. You ignore some outliers because any reasonable data set needs to have outliers. If you don't have outliers, it's good. You find the trend, and there you go. And that's the end of my talk. Thank you very much.
So next is Simon. We are hiring.
Hi. So I'm not a funny talk. I'm an artifact. We are hiring. Some senior positions are on our website. More junior positions, please just send us your application and we'll see where we can fit you. So these are not just in Europe, but also in the US. Talk to us. We are here with 9 people, including myself. They're making noise back there, so that's about it.
The next is Colin, a secure HPE scheme.
All right, so I have some concerns over the judge's impartiality and the topic of this. So we see. So a secure HPE scheme. HPE, of course, is a homomorphic pizza encryption scheme. And why would you want a secure HPE scheme? If you've ever ordered a pizza, there's a lot of pizza threats, right? So side channels, of course. So there was this classic attack, right, of the pizza ordering in Washington's related to the, what sort of wars are happening in the world. The US always has wars, so of course. The delivery driver steals your pizza. And in particular, we want homomorphic pizza encryption, because what if the chef doesn't like your pizza choices? So this is sort of where it's very important. And there's some concern. So the scheme looks like this. You have your order that is encrypted. Now, the important thing is the ingredients themselves are transformed. So when we cook the pizza, this is done homomorphically. So the chef doesn't know what pizza you've ordered. And then you get the pizza, the delivery driver doesn't know, and then you decrypt it and eat it. So this is a scheme that I think people will find interesting. I'm not sure everyone will. And in particular, I really wanted it because there's a pizzeria that I grew to know a bit, and they were Italian. And I really wanted to order pizza Hawaiian.
Get out on stage, get out. This is not valid. This is not. We were supposed to be friends. So next is the TII Michaelis Challenge. Francisco.
How do you come back? Oich. Oich. Yeah. Same as Diego. Okay, I want to present today the TII MacList challenges. This is a challenge that is presented by the Technology Innovation Institute and by my colleagues, Emanuele Bellini, Andre Esser, and Elena Kirsanova. So the motivation and goals of this challenge are enhancing the understanding of security. This is the foreground of the NIST PQC effort that, as you know, is purely code-based, meaning that the schemes BIKE, HQC, and Classic MacList are there. And MacList being the most conservative candidate with a unique security foundation. So the outcome of this challenge is going to be relevant for other code-based schemes. We are considering different categories. One of them is message security. So how to recover a message M from a given ciphertext C. For all the schemes, we have this as the syndrome decoding problem. This is the problem. The information set decoding is the best known strategy. And we want to determine parameters. With this challenge, we pretend to improve potentially to have improvements in the parameter selection and a better understanding of how to enhance the parameters that we already have. On the other hand, we also have a second category, which is the key security. This is less visited by people. How to recover secret key as key from a given public key. So this is a fundamentally different problem for MacList. And all known algorithms are rather naive enumeration approaches. So for instance, if you consider MacList category 1, the message security is around 143 bits, but the key security is greater than 3,000 bits. So there is no big incentive to study key recovery until now. We want to correct this. And this is how we present our challenges. We will have 3 different tracks, as I was mentioning. This started already in May 2023, so you better hurry up if you want to apply for these challenges. The duration is approximately 1 year. And the first category is about, is what we call a theory track, is presenting a paper that we find that is the best paper in the subject of MacList key recovery. Who wins the best paper under our discretion? This is the first category, and the price is, the bounty is $10,000. The second category is about key recovery. We are considering challenges that go all the way from 40 bits to 255 bits. And who wins? Whoever gets the higher size in the recovery. And the price is up to $10,000 US. And the third category is the message recovery. In this case, we are offering the bounty of $55,000, and is message recover from going from all the way from 33 bits to 90 bits. Who wins? Whoever is the record holder at the time that the challenge closes. So please apply. We are waiting for your applications. More details here. Thank you very much.
Next is CHES and more. Anton.
Hey everyone, I'm very happy to introduce the CHES and More loyalty program. Okay, this has been 24 years of CHES, 25 editions. Many people here are loyal to CHES. Many of you have been recognized already today, but there's some heavyweights in the community. We want to give more privileges. So that's what this loyalty program is about. And we're celebrating 24 years of you. Okay, that's you. So CHES right now, if you're an attendee at CHES, everyone is kind of equal, right? And that, my dear friends, is something we would like to change. Because not everyone is equal in terms of loyalty to CHES, okay? So what we're introducing is a concept called CHES miles, okay? You can accrue these CHES miles through various ways, which I'll go into details later. But let's take a quick look at some of the privileges that these CHES miles can buy you. First of all, we're going for a random seat allocation. So if you have 1,000 CHES miles, you can purchase an aisle seat. So you can go to the coffee quicker, or if there's a theory talk, you can run away faster. Something else that our longtime CHES audience will appreciate is the opportunity to buy afternoon speaker slots, okay? So you don't have to worry about having to present tomorrow morning, for instance. That's a problem of the past. Major revisions are a breeze for people with CHES miles, because you can turn major revisions into very mild minor revisions with only 20,000 CHES miles. And if you want to have some more pages in your paper or some more speaker minutes, this is an ad hoc fee we can negotiate when the time is right. But how do you accrue CHES miles? So CHES miles, okay, if you register, you get CHES miles. If you pay more, you get more CHES miles, obviously. If you get a stipend, yeah. You can review a paper, 5,000 CHES miles, chair a session, 10,000 CHES miles. If you want the big bucks, you chair the conference, 300,000 CHES miles await you. But it's not only CHES that can earn you miles. We have a partner program with the IACR Alliance, with which you can accrue and use CHES miles. Besides all these ad hoc things, we also want to recognize the status of some of our very heavy lifters in the community. So with 10,000 CHES miles, you will permanently obtain fast lane access to lunch, coffee, beer, anything you'd like. But gold members with 100,000 CHES miles, they will never have a reviewer B. It will only be reviewers A, C, D, and E, significantly raising the success probability of any paper you're on. But you know what's coming. Platinum members with over 1 million CHES miles have the exclusive privilege to make use of our once-in-a-lifetime facilities of having a student daycare where you can dump all your students, and we will make them spend their day in a lovely manner, occupying them with toy projects such as implementing Kyber in Jasmine without function calls. So thank you for your loyalty. Thank you for 25 CHES editions. And don't let your loyalty be unrewarded. Start earning today.
So next is the Cardis 2023, Shivam. Also Thomas, sorry.
You know how this works? Hi, everyone. So, can you guess this place? It gets better at night, right? There's some good stuff out there,
They have some cheese. They have some bitter balls, some waffles, and also for the vegans, they have other stuff. So we would like to welcome you to CHES 2023. It's organized for 15 and 16 November in Amsterdam, NL. And these are some of the details. Wait, the slide is not moving because it's a boring slide. You will see that. Yeah. So in this boring slide, you'll see the dates and who are the people who are suffering. And also, yeah, we will also have a pre-conference tutorial. So please be there and enjoy the rest of the evening.
Next is this constant time? Gustavo and Florian.
Let's warm me. Welcome.
Hey people, so we have the perfect drinking game to set the mood of the Rump session, as it's the beginning. Right. Anyway, how does it work? It goes, yep.
Yeah.
So the principle is quite simple. We're going to show you C code and the compiler, and then you have to guess if it's constant time or not. The thing is that if the majority of the audience gets it right, we drink, and we encourage you that if you don't get it right, you drink.
Wait. Since we are the last one, I think we can have a little bit of more time because I see empty glasses here.
Yeah, you
empty
should refill
glasses
if you have time.
there, empty glasses in the end. So you should refill, please. Just go and refill. Yeah,
Wait
thank
for
you.
Good.
Thank you. Yeah, thank you, people. You are amazing. I love my audience. Yeah. Also, for who remembers, let's say who remembers AI. Woo, thank you.
I forgot how to drink.
Yeah. So in the like, let's say in the
meantime,
we
don't have a joke.
We might just say, like, connecting to the previous talk and say, if you get right, you gain like 10 Gryffindor, 10 like CHES Mile points.
We should put that if you agree, Anton.
Yeah, we should.
Hmm?
No, people. Thank you. Thank you,
You agree?
Anton.
Good.
Amazing. You're love you.
How many CHES Miles then?
That's the answer for everything, life and everything else. So in the meantime, you should not use, but I think no one has a computer now to use. And should at least we show one for,
okay, we can start for the first one. That one's for us anyway. So
yeah,
here it is. It's the dilithium modulus, and this function returns the mod Q from UIN64. Is that constant time?
Thank you. Okay, so be aware that we are like also using one specific compiler.
Yeah, that's true, on the Cortex M4.
So who is like thinking that it's constant time? We have 1, 2, 3.
We have thirsty people.
Yeah, okay.
Good. Wood doesn't think it's constant time. Like,
well,
seriously, not even 10% of the audience.
Wait. The rest of them do answer. Have you ever coded in your life?
Yes, seriously. It's all fast.
It's fast.
Crypto has to be fast.
It's fast. That's
all
why
fast is fast.
Okay.
Okay, so obviously it does not, right? It's like there is this thing in the middle, the branch to UA, AAB, you will div mod. Okay. Whatever shit it is from GCC or CLang in that case.
So now you got wrong, you drink.
We drink, yeah.
Cheers.
Okay, next one is more tricky.
Same thing, different compiler with OFAST.
No, it's the same compiler. There is a small difference though. So who says it's constant time? Come on, don't... Okay, who thinks it's not constant time?
Who never coded in their life?
Okay.
Who doesn't like C? Thank you.
Good. Well, actually, it is constant time. Because it's a fixed modulus, and CLang and GCC are doing some magic with some magic number. Like you can see this 1 billion thing. So that's a magic number. That's constant time. So you can use it like for Kyber, for example.
Just use
Good. Is it constant time on an M3?
We are drinking this one.
Who says it is? Okay, who says it's not? Okay, we're drinking. Why? Is because of this U mule here is not constant time. Good job for the people who attended last day tutorial, actually. So we have one which is from HQC. I hope you can see it. So it computes like an absolute value somewhere in the loop, and then it does some weird shit. But the funny thing is the comment. All compilers nowadays compiler will compile with a conditional move.
Please.
So does CLang compile it with a conditional move? Who says no? Okay, who says yes?
Who doesn't care anymore? Just want to drink?
Good.
Yeah.
Well, actually, CLang does it. You can see there's a bunch of C move, and it's all good. Actually, I mean, if you think that C move is constant time
one.
Okay. Does GCC? Same code, just a different compiler. It's a nowadays compiler. The version is the latest one. So who thinks it is constant time?
You really want to drink. You really want to drink. We have 1, 2, 3, 4,
Okay,
5.
and who thinks that GCC is fucking it up? Okay, you're
Okay.
good. So we drink that one.
Yeah, we drink.
Oh,
we drink. Oh no, yeah.
I'm empty, actually. I need one more. Okay, and now if you do array comparison in RISC-V, so that's the RV32 GCC lang, with a big fat if in the middle of the loop, who thinks it's constant time?
1, 2.
Thirsty people.
I really like how people are really engaged. Like, yay.
Yeah, and who thinks it's not constant time?
We really don't care about like being constant time.
Okay, well, anyway. So it is not constant time. There is a branch equal here. It does a load immediate after. So no, it's not constant time. So how can we fix it? Let's do weird stuff. Let's put an end.
It should be constant time, right?
So who thinks that one is constant time? Stop it. Who thinks it's not constant time?
Oh, nice.
I think we might not drink.
Yeah.
So it is constant time. That one it is. So we don't drink that one.
Yeah.
Okay, so we did with an and. What if we do with a multiply? Who thinks that one is constant time? There's
There is
one guy there.
Thank you, Ralph.
Thank you. And who thinks it's not constant time? Oh shit.
Yeah.
Okay, that one is not. It compiles exactly as the first one. Cheers. Okay, and last one.
We promise.
Who thinks that updating the compiler version fix the if? So is that constant time? Well, it's not. No, it is actually, sorry. Anyway, so you actually, if you upgrade your compiler, it does constant time thing.
Yeah. So,
and that's our last one.
Yeah.
Thank you. If
Thank
you have
you.
other examples, please send it.
Okay, it's now time for 2 prizes. The first is the best Rump session presentation, and I give to Guido the honor.
We are very happy to welcome on stage Anton Pumai for introducing CHES and more. Thank you very much. Do you want to say something?
I'd like to thank my mom
That's about it.
On the price.
The price is yours. So it is the 6-pack actually. So 6 beer of Primator beer, six bottles of Primator beer. So and it is good. It has been cooled, so you can drink it immediately.
Thank you very much. Thank you very much. Are you putting chess miles on a blockchain? You don't have
Giving
to
now also chess miles for winning the Rump session.
And
now it's time for the second prize, which is the best almost Rump session presentation. What's an almost Rump session is a person that have been stalked to submit, but they didn't do it at the end. We have 2 runner-ups. One is Mark Stöttinger. Please clap. Big round of applause for Mark. You want to say something?
I feel like an artifact.
please tell us the best excuse.
The best excuse is you said to Francesco, I'm not going to submit. He tries to persuade you all day. Yeah.
Thanks.
Yeah.
You are not alone.
The second runner-up is Elif. Clap. Big round of applause for Elif. Yes, promise I would call anyway.
So what was my excuse?
I don't know.
Exactly.
But the winner is Timo Kasper, please. He also has a prize, an empty bottle of wine.
Grazie mille, Francesco. It was just that I wanted to avoid this, but Francesco finally made it happen that I'm here. So I'm Timo from Germany. So this is a serious Rump session talk. And I want to announce I don't know where to start. It's my dream since years and years. And now the health minister of Germany has changed a law. It's about the law of consuming marijuana and weed in Germany, so now it becomes possible, and I can announce something. Next year in Germany, there will be in Bochum a new conference, 2024. I will announce the exact date. It will be in Bochum, and it is secure hardware implementation techniques. So short shit. Sorry, I didn't provide any slides. And I ask everyone to submit at least 5 shit papers to the Secure Hardware Implementation Techniques Conference in Bochum. There will be LNCS proceedings. That's why you submit 5 papers each. You can use the paper generator as invented on CHES Rump session 2021 and just submit at least 5, so we have a good acceptance rate. We guarantee a very fair review process because we are using a fair dice. And we hope that to see many of you next year in Bochum for the SHIT conference. So thank you. And thanks to Francesco for the empty bottle of wine.
So thank you all, and we still have time, I think, for enjoying some drinks. So
Thanks for joining.
Thank you. Bye.